Section R2 is on properties of exponents and roots. We have several concepts to cover here. So the first one is properties of exponents. Okay, so our properties of exponents. B to the 0 is 1. B to the negative n is 1 over b to the n. Let's see if I can show you some reasons as why this is true. Okay, you don't have to write this down, by the way. So let's say we've got 2 to the 4th. We know that is 16. 2, let's see, what should I do next? Squared is, no, let's go back. 2 to the 3rd is 8. 2 squared is 4. And 2 to the 1st power is 2. Okay, so what I need you to notice over here is that each time we've got 16, 8, 4, and 2. So what's happening? Each time when we go from 16 to 8, we're dividing by 2. When we go from 8 to 4, we're dividing by 2. When we go from 4 to 2, we're dividing by 2. So if we want 2 to the 0th power, we're going to divide by 2 again. And 2 divided by 2 is 1. So that's just a quick little example of why a number to the 0th power is 1. That would work if we use 3 or 4 or even a negative number. Keep going down to 2 to the negative 1. Well, this time, if you divide 1 by 2, then we have 1/2. So notice that 2 to the negative 1 is 1/2. That's 1 over 2 to the 1. Our 2 goes to the bottom of our fraction, to the denominator. So that is a quick reason as to why a negative exponent takes us down to the bottom of our fraction. Okay, so there's explanation for the first two. Okay, so for the third one, we've got b to the m times b to the n. And we're told that that's b to the m plus n. Now, why is that? Let's say we've got b to the 3rd times b squared. Well, b to the 3rd is b times b times b. Times b squared, that's b times b. Notice that's 1, 2, 3, 4, 5, b to the 5th. So what have we done? We've added the exponents, 3 plus 2, to get the 5. With the fourth property, we've got b to the m over, divided by b to the n, is b to the m minus n. Why is that? Well, let's say we have b to the 3rd over b squared. That's b times b times b over b times b. b over b is 1, so they cancel out. And we're left with just b. So here you can see that b to the 3 minus 2 is b to the 1, or b. So that's why those work like they do. Okay, the next property is b to the m to the n. Okay, so let's say b to the 3rd squared. What does that look like? B to the 3rd squared. So that's b to the 3rd times b to the 3rd. That took care of our squared. And then we've got b to the 3rd. So b times b times b times b times b times b, and that gives us b to the 6th. And so that shows you why b to the 3rd squared would be b to the 3 times 2, or b to the 6th. Then we have ab to the m, and that is pretty self-explanatory there. Basically, our exponent will go with everything in the parentheses. So we have a to the m times b to the m. And same thing when you divide. A over b to the m, you're going to put the m with the a and with the b, so that you have a to the m over b to the m. So let's look at several examples here. We have 6y to the 0th power. Well, anything to the 0th power is 1. So basically this is 6 times 1, which gives us 6. For part B, negative 5 to the 0th power. Since this is not in parentheses, if it were in parentheses like that, then negative 5 to the 0th power would be 1, period. But since it's not in parentheses, then it's just the 5 being raised to the 0th power. So we keep our negative, and 5 to the 0th is 1. So our answer is negative 1. Here we have 5 to the negative 2. Well, that would be, a negative takes it to the bottom, so 1 over 5 squared, and 5 squared is 25. Okay, we know that the negative exponent takes our number to the bottom of a fraction. Well, if it's already on the bottom, guess what? It takes it up to the top. We don't want to keep a negative on the bottom of a fraction. That's technically not allowed. So our p to the negative 4 goes to the top, and we just have p to the 4th, and that's it. Then for this last one, we have 5. The x to the 8th goes to the bottom, and y squared stays on top. There's nothing that can cancel out there, so we're simplified. Okay, so let's look at one that's a little bit bigger. So here we've got 14a squared b to the 7th over 2a to the 5th b. Okay, first of all, you're going to take your numbers, and you're actually going to perform the operation. Okay, so in this case, we've got 14 divided by 2, and that's just 7. So a 7 stays on the top. Then with our a, we've got a to the, and we've got a 2 on the top and a 5 on the bottom. So that's 2 minus 5. And for b, we've got a 7 on the top and a 1 on the bottom, so that's 7 minus 1. That gives us 7a to the negative 3, b to the 6th. To simplify that, we take our a to the bottom. So we've got 7a cubed on the bottom and b to the 6th on the top. Okay, for this one, we've got a negative squared on the outside. So what that means for us is we've got 3a squared to the negative 2 over a to the 5th b to the negative 2. Basically, it just means to flip things. So we've got a to the 5th b quantity squared on top now, and on the bottom goes our 3a squared quantity squared. Then we're going to square everything on the inside. So we've got a to the 5th times 2. And b, it's just 1 times 2. So we'll just go ahead and write 2. And on the bottom, we do square the 3. So we've got 3 squared, and we've got a squared times 2. So we end up with a to the 5 times 2, which is 10, b squared, over 3 squared, which is 9, a to the 4th. Well, we're not quite done, because you notice we have a's on the top and the bottom. So we've got a to the 10 minus 4, b squared on the top, and we've taken care of that a on the bottom, so just 9 down there. 10 minus 4 is 6, so we've got a to the 6th, b squared, over 9. Now you could also do this where you just kind of cancel out the a to the 4th and the 10 up here, and you've got 6 left. If you want to go ahead and write it like that instead of writing out the step to subtract. It's up to you. And we get bigger. So this time we've got negative 3 times x all to the 4th power. So we're taking negative 3, raising it to the 4th power, and x, raising it to the 4th power, and then this stuff in the parentheses here, we've got 4 to the 3rd power, x squared to the 3rd power, so that's x to the 2 times 3, and then y cubed to the 3rd power, so y to the y cubed times 3. Notice I put the negative in the parentheses here, and that's because it's in the parentheses up here. So we are raising to the 4th power the entire negative 3. So that gives us negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. So we end up with 9 times 9, which is positive 81. Then we've got x to the 4th here. We've got 4 cubed. That is, let me just double check my work here. Oh, that's not right. 64. That's what I thought. Okay, so 64. Then we've got x to the 2 times 3. So that's x to the 6th. And y to the 3 times 3 is y to the 9th. Little bit more work here to be done. We need to multiply 64 and 81. That gives us 5,184. Then we've got x to the 4th and x to the 6th. So add those exponents. We've got x to the 10th and then y to the 9th. And that's as simple as it can go. Part D. Okay, I know they're getting bigger, one thing at a time. So here we've got a to the negative 4th power. We can start by writing that on the bottom, or we can just go ahead and distribute through. Let's start by writing on the bottom. I think that'll make it a little bit easier to see. So on the bottom of our fraction goes our negative 3x to the negative 4th. Little mark there. Okay, and then on top we have 4x to the negative 2. We'll worry about that in a minute. Y cubed, and then all cubed. And I was supposed to get rid of that negative, wasn't I, when we moved it down? So that's just to the 4th power. Okay, so take that cubed on the outside and let's essentially distribute it through. So we've got 4 cubed, and then we've got x to the negative 2 times 3, and y to the 3rd times 3. On the bottom, we've got negative 3. Notice I'm putting in parentheses to the 4th times x to the 4th. Keep simplifying. So 4 cubed is 64 again. Negative 2 times 3 is negative 6. So he's got x to the negative 6, and we'll take care of that in a minute. And then we've got y to the 9th. On the bottom, 3 to the 4th power is 9, and since that's negative 3, it's a negative 4 times. And so anytime we have a negative to an even exponent, we're going to end up with a positive number. If it's odd, then we'd end up with a negative number. So we've got positive 81 x to the 4th. Okay, so 64 and 81. Let's see, does that reduce any? Nope, it doesn't. Okay, so we'll keep that there. 64 on top and 81 on the bottom. Our x to the negative 6, that's going to go to the bottom. And so now we have an x to the 4th and an x to the 6th on the bottom. And we'll go ahead and add those. We end up with x to the 10th. And then on the top we have y to the 9th. And that's as simple as it'll go. Evaluating nth roots. So for a positive integer, the principal nth root of a is denoted by the nth root of a. So we've got it looks like a square root, but it's not. If we were to write a square root of a with a number there, we would write it like this. But since square root is used so often, some old dude long time ago decided that we could take that away. But anytime we use anything but a square root, we have to put the number there. And so the nth root of a, if that's equal to b, then that means b to the n is a. So basically, if the square root of 25 is 5, then that means that 5 squared is 25. Okay, so that's just putting that out for us to explain. And until we look at imaginary numbers, we require that a be positive. So, what do we do if we have a fifth root? Okay, if we have a square root, let's just go to the side and look at this. You don't have to write this down. If we have a square root of 25 again, then that is the square root of 5 times 5. And what I like to do is square root, that's 2. So that means we've got 2 of these guys, and it will come out as just 1 without the root. So you'll see what I mean when we look at this example. So what we've got is the fifth root of 32. Well, we have to take 32, and do write this down over to the side somewhere, and break it down and see what we've got. So 32 is 2 times 16. We're going to circle this 2 because that's as far as it can go. Then we have 16 is 4 times 4. That can keep going. 4 times 4 is 2 times 2, and times 2 times 2. And so that as far as those 2's can go, then we circle them. And so what we've found here is that 32 is, all those 2's circled, 2 times 2 times 2 times 2 times 2, which is convenient. So the fifth root of 32 We're going to write down all these 2. So we've got 2 times 2 times 2 times 2 times 2. Notice that there are 5 of them. So anytime there's the number in the root, we circle those, and it brings out 1. So the 5th root of just 2. Okay, if you didn't understand that, we're going to look at several more of them. So here we've just got square roots. We've got the square root of 9 over square root of 49 over the square root of 64. Now this one we probably already know. 49 is 7 times 7. And I'm going to go ahead and, you don't have to write it out like this in the future, but just for consistency's sake, I'm going to go ahead and do it now. And the square root of 64 is 8, so that's 8 times 8. Since it's a square root, we're looking for pairs of 2. So that brings out a 7. And square root on the bottom, so we're looking for pairs of 2. That brings out an 8. So the square root of 49 over the square root of 64 is just 7 over 8. Okay, I thought we said we can't have a negative. So, let's see. Since it's a 4th root, yeah, there's nothing we can do with this at this point. We could have 4 negative 1s. But that would give us a positive 1, so yeah. Basically, as far as we're concerned right now, this is undefined. We'll look at imaginaries later and be able to go further with that. Okay, now we can have a negative if it's a cubed root. So, in this case, let's see, 0.008. If we break that down, we've got 0.2 times 0.2 times 0.2. That gives us 0.008. Now what do we do with the negative? Well, if it's a cubed, then we can actually just bring the negative, and I need a 3 in there, the negative to the outside. Now the reason for this is, let's go to the side and look at this. If we had the cubed root of negative 1, well, that could be the cubed root of negative 1 times 1 times 1. That gives you a negative 1, right? And so you've still got your pair of 3's, and that would come out to give you a negative 1. Okay, so because of the odd root, then we are allowed to have a negative, and we bring it out to the front. Now we've got our group of 3 here. And so this will give us negative, since we've got 3 of them, 0.02. This time the negative's on the outside, so that's all good. Any root of 1 is just going to give us 1, okay? 1 times 1 times 1 times 1, bring it out, you're good. So the negative's on the outside, and we're just left with 1. So the fourth root of 1 is just, or negative times the fourth root of 1 is just negative 1. Next, what if we have rational exponents or fractions in the exponents? Okay, so we've got this rule here, and it says a to the 1 over n is the nth root of a. Okay, why is this? So let's look at a little reason here. So let's say we've got 2 to the 8th. 2 to the 8th power is 256. I'm going to go down to 2 to the 4th. 2 to the 4th power is 16. So I've halved my exponent. 8 divided by 2 is 4. I'm going to half it again. 4 divided by 2 is 2. And we know 2 squared is 4. Okay, so what has happened here? Well, so basically, we've taken the square root each time. If you take the square root of 256, you get 16. If you take the square root of 16, you get 4. So what's going to happen if I take the square root of 4? I get 2. That's 2 to the 1. I've halved the 1 again. Okay, if we half the 1 one more time, we've got 2 to the 1/2. So this time, we're taking the square root of 2. And it's just the square root of 2. So, that's just a little example to see why, if we've got a fractional exponent, why that gives us roots. So this is the square root of 2. And to point out here over to the right, if we've got a to the m over n, just like the denominator of our fractional exponent goes into the root here, the denominator of our rational exponent goes into the root here. The m, the numerator, stays with the a and just raises it to the power as here. And so we have the nth root of a to the m. And you could rewrite that, if it helps you solve it, as the nth root of a to the nth power. Either way you look at it is correct. So let's look at some examples. So 25 to the 1/2. That is the same thing as the squared root of 25, which we know is 5. Done. So part B, we've got cubed root. So this is the same as 64 to the 1/3 power. Remember back in our exponent properties, and 27 to the 1/3 power. Okay? So we have the third root, or we say cubed root, of 64 over the cubed root of 27. So that's how you write it, and we do want to reduce that. So 64. Let's see. If we go over to the side and take 64 and expand it out, it's actually 4 times 4 times 4. And we could go further with 2's, but we don't need to bother. And then on the bottom, 27 is the same thing as 3 times 3 times 3. So notice on the top we've got our group of 3 4's. And so that comes out as a 4. And on the bottom we have our group of 3 3's. And that comes out as a 3. We have negative 81 to the 1/4 power. Well, that is the same thing as the fourth root of negative 81. And we've already talked about we can't have a negative at this point anyway, underneath the root, as long as we've got an even root. Okay, so this one for now is undefined under the real numbers. Okay, so let's see what we have here. So remember the denominator, the bottom of the fraction, goes inside the root. So we have the fifth root of 32 to the third power. You could also write this, I think it'll be easier for us to look at it, if we say the fifth root of 32 to the third power. Because we've already found that the fifth root of 32 is 2. So we've just got 2 to the third power, that's 8. (81) to the negative 3/4. Let's see what happens here. So the 4 goes in our root, and we've got 81 to the negative 3. Well, that's okay, because our root is positive, or our actual 81 isn't negative, so we're good with that, okay? Let's rewrite this as we did with the last one. I think it'll be easier to look at if we say the fourth root of 81 to the negative third power. So the fourth root of 81. We've already talked about this a little bit. It's 3, but we'll go over to the side just to verify. 81 is 9 times 9. We can bring that down more to be 3 times 3 is 9. And the other 9 is 3 times 3. And so we've got our 3's as far as we can go here. And there's 4 of them. So we've got the fourth root of 3 times 3 times 3 times 3. And we'll stick our to the negative third power on there. We've got a group of 4 3's. So that leaves us with just a 3. 3 to the negative third power. That's the same thing as 1 over 3 to the third power. And to go ahead and multiply that out, 3 to the third power is 27, so we have 1 over 27. So that's the end of that. I want to point out one other thing. Let's say we have something like, just look at a simple one, the square root of 8. Okay? I just want to point out what happens when you've got something left under the radical that doesn't get rid of the radical altogether, like we've done in our examples so far. So here, 8 is 2 times 2 times 2. So we've got the square root of 2 times 2 times 2. Since it's a square root, that's a 2, then we need a group of 2. So that group of 2 comes out as a 2, and the 2 under the radical stays under the radical. Okay? I just wanted to point that out.